Hello, everybody. So this is an informational video for the law of reflection proof, a physics lab, which is referring to one of your week 11 labs that we're going to take a look at as well. So to start, we're going to go to slide number 2. And in slide number 2, it says explain the law of reflection and how the angles are measured. You pretty much have it right here in this picture. You have an incident ray of light, an incoming incident ray of light. And all of a sudden, there's a mirror on the floor, and this light is reflected. Now, the angle of reflection needs to be the same for the incident ray as well as for the reflected ray. And that is what we're trying to prove here. That is what we're trying to prove. And so we go to slide number 3, and this is just an imagine Big Bird is reflecting light onto Super Grover. You don't need to make up any data over here because this is just giving you an example. The data that you're going to have comes from your lab, your law of refraction proof, a physics lab. This is from week 11. This comes from your week 11 lab, and so you already have data. You already wrote numbers. You already did this experiment, and so this is the data that you are going to use. Okay. So we are going to put these numbers in the in our write-up. So the incident light eye level height is 67 inches. Okay, so this is just some data that I made up just because I don't want to give you the answers. That's all. Okay. So incident light eye level height 67 inches. Okay, so we're gonna do that. And that is going to be you're going to put this information in the fourth slide. Okay, so I already added text boxes. Okay, I already added text boxes, and so now we're going to write that info. So the eye level height of the incident light is 67 inches. Okay, all right, so let's do that. 67 inches. 67 inches. Okay. The distance from the mirror, or the distance from the person that has the light at eye level, that is 86 inches. Okay. So we're gonna write it over here. 86 inches. Okay. Sounds good. All right, 86 inches, and then the distance away from the mirror in the reflected side is 25 inches. And again, this is just made up data that I used, but you already have numbers. You already have these numbers. So please don't use these numbers, everybody. So 25, I'm just giving you an example on how to do this thing, okay? 25 inches. And then the reflected light eye level height is 78 inches, okay? So 78 inches. So 78 inches. And so I'm getting just my data from the lab that I already did. And please notice how it says list your data in meters. Okay, so 67 inches. Okay, so I go to Google and I say 67 inches into meters. Press enter, and so now it gives it to me. All right, so it's 1.702. 1.702. So in meters, This is 1.702 meters. Okay. And 86 inches, let's see how much is 86 inches. 86 is 2.184. So 2.184. 2.184 meters. Okay. 25 inches. Let's see, 25 inches. 0.635 meters. 0.635 meters or 63 centimeters. And 78 inches. 78 inches. 78 inches is 1.981. 1.981. Okay. So 1.981 meters. Okay, awesome. So there you go. That's how that wasn't that bad. Okay. So now I'm gonna use this data. I'm gonna use this data in meters. I'm gonna use this data to calculate the angle at which this light is being of this incident of light. If we explained it right, it says that the angle of incidence has to equal the angle of reflection. Okay, so we're gonna have to calculate both so that we prove. Okay, we have to calculate both so that we prove that in fact the angle of incidence is equal to the angle of reflection. Okay. And so we gotta use SOHCAHTOA for that. And to use SOHCAHTOA, everybody, to use SOHCAHTOA, let me take you to the week 7 folder. The week 7 folder has notes, all right? It has problems, and it has more problems, okay? It has a sample problem, okay? Folder 8, week folder 8, week 8 folder, sorry about that. So if we go to the week 8 folder, again, Monday PERDEC on SOHCAHTOA. And it also there's a tutorial video on SOHCAHTOA problems, okay? So there are resources out there available to you. If you don't remember what SOHCAHTOA is, I would suggest that you go to the week 7 and week 8 folder, okay? There's plenty of information in there, all right? All right, so let's go back to our problem at hand. And so I have information. So this is the angle that I'm trying to calculate right here. Or here you can see a little bit better. This is the angle that I'm trying to calculate. And the side that is right next to this angle, the side of the triangle that is right next to the angle is the adjacent side, okay? Is the adjacent side. Now, there's another angle, there's another side next to this angle, but that is the hypotenuse. How do I know that it's the hypotenuse? Because it's on the opposite side of the 90-degree angle of this triangle, okay? There's a 90-degree angle right here. And so the opposite side of that 90-degree angle is always the hypotenuse, okay? So with relation to this angle, the adjacent side is the one on the bottom. Now, on the opposite side in reference to this angle, this is the opposite side. So let me highlight it a little bit. Okay, so this is the opposite side right here with reference to this angle. So the opposite side is the opposite is on the opposite side of the angle. That is It's just the location, everybody. It's pretty much just the location, okay? So with reference to this angle, the side right across from the angle, the side right across from the angle is the opposite side. And the side right next to the angle is the adjacent side. And the side right across from the 90-degree angle, is the hypotenuse. Okay, and so we have our triangle, and so we have that our information has the adjacent side, the length of the adjacent side, and we have the length of the opposite side. Okay, that is the information that is given to us, and so we have opposite and adjacent. And so if we come over here, let me remove my spotlight. And so if we come over here, we are going to use opposite over adjacent because that is the information that we have. And that is what tangent is. That is this part of the TOA. The TOA is tangent of the angle equals opposite side, the length of the opposite side, divided by the length of the adjacent side. Okay? And so now we go to try to, so again, we are looking for the angle. We are looking for our angle number 1. That is what we are looking for. And so the length of the length opposite side is equal to 1.702 meters. Okay, 1.702 meters. And the length of the adjacent side is equal to 2.184 meters. 2.184 meters. 2.184 meters. Again, please use your own data. Please don't use my data, okay? Please use your own data, the data that you collected in these boxes, okay? Please use the data that you collected in these boxes, okay? And so now we are gonna plug in our information. So tangent of our angle is equal to the opposite, which is 1.702 meters, and that is divided by 2.184. 2.184 meters. Okay. And so now how do we solve for, well, what do we do now? Well, we just divide, everybody. We just, that's pretty much what we're going to do. We're going to say that we're going to divide 1.702 divided by 2.184, okay? And we're going to get a result. So let's just set up the problem. And so we're going to go to our trusty calculator. And it's, let me see, 1.702. 1.702 divided by 2.184. Divided by 2.184. And that is equal to 0.779. 0.779. Oops. 0.779. Okay? So now what do we do? So now how do we solve for our angle. This is what we're trying to find, the angle. That is the measurement that we are trying to find. Well, in class, I went over what is called inverse tangent. And that is a button on the calculator. Inverse tangent is a calculator button, okay? And it looks a little bit like it looks similar to tangent, but it's tangent to the -1. So that is the inverse tangent, everybody. The inverse tangent is tangent to the -1. And so we are going to apply the inverse tangent to both sides of the equation. Okay, we're going to apply inverse tangent to both sides of the equation. And so we're going to do that by saying, okay, well, on one side, we're going to do tangent to the -1. And then we're going to do the same on the other side. Tangent to the -1, okay? And let me just fix this really quick. There you go. Okay. And it turns out that when we apply inverse tangent to a regular tangent, well, guess what happens? Guess what happens? They cross out. They cancel each other out. Okay. They cancel each other out. Okay. Oops. It's not that much. Okay. They cancel each other out. And so what we are left with, everybody, is at, which is our angle. Angle is equal, oops, so let me do black, is equal to inverse tangent to the -1 of 0.779. So let me fix this really quick. Okay, that is what we have. That is what we want. Okay, that is what we want, everybody. And so now I'm gonna plug this into my calculator. Everybody. Okay, and I'm gonna go to my calculator. And I'm gonna make sure that it is on degrees. Okay, and if you see this button, this is INV, or inverse, and I'm gonna click on that. And look at that. There's the tangent to the -1. So now I'm gonna click on that, and I'm gonna say, okay, 0.779. Okay, 0.779. All right, so tangent. Oops. Let's try that again. Okay, so that's my inverse. Okay, of 0.779, and I get 37.919. Okay, which could be just 37.92, in other words. Okay, so my answer is that the angle measures angle at 1. Okay, angle at 1, is equal to 37.92. Whoops, sorry. 37.92 degrees. And that is my answer for number 1. That is my answer for number 1. Okay. And so now I need to verify that 37.92 is also this angle right here. Is also this angle right here. And so you do the same. You pretty much do the same work. Okay. You pretty much do the same work that you did here for number 1. You do it for this side. And if this angle is not the same as this angle, then you did something wrong. Sorry to say, okay? And you kind of have to tell me what it was that you did wrong, okay? Let's see. So that is the math behind that. And so now explain how to calculate the reflected and incident angles based on the normal line. And so if you notice, angle of incidence is on the top, angle of reflection is on the top. So you have to tell me, you need to tell me, well, this is the angle that we calculated, and this is the incident angle, and this is the reflected angle. So how do we calculate the incident angle and the reflected angle? You tell me. Okay, and based on your data results, what is your conclusion on incident and reflected light? Why do you think this happens? Okay, and if it didn't, if the angles don't match, if you could please explain to me why you think that was. Okay, and that's all that this lab is about. All right, have a good one.